Yeah, so last time we looked at we looked at attacks and attackers, and I think that was enough preparation for this next module, which is network monitoring, because you can't monitor what you don't know. So at least you need to have an idea of what you're monitoring, and that's why we went through attackers. They're different. We initially looked at the network architecture and where you can install the security tools. We looked at a different number of those, like we looked at the SIME tool, not the SIME, we looked at the IDS, IPS, we looked at the firewalls and the different types of firewalls, and then we moved on to look at the different types of attacks. We talked of risk, and today we are looking at the network monitoring and the tools. Yeah, now that we know the kind of attacks that we will be expecting, and we have an idea of how attackers operate and what they leave behind. So when we're looking at the monitoring, we know what exactly we are looking for. We're looking at IPs, are we looking at the domain names, the DNS record, and things like that. And so so we look at monitoring and the tools that we use to do that, which is a very important thing in SOC. So we're going to explain the importance of network monitoring, and we're also going to explain how network monitoring is conducted. It's a very short session, so we'll not really take a lot of time in going through this module. So network monitoring is just observing, having a look at the things that the activities that are taking place in a network, and that means we also have sort of rules in place. Some of those devices have been configured with rules that enable those devices to be able to tell whether we have a bad actor or a malicious traffic getting in or even out. Yeah, it can be a form of insider or from outside, sort of attack. So the tools should be able to capture that and notify anyone who is monitoring all the data, all the logs, in form of a dashboard. And also those tools have some sort of they have the ability to send notification and notify the analysts. The analysts are the people who are looking at who are monitoring the network. Yeah, and they're normally in three groups, as we saw at the beginning of this course, that we have three types of analysts. We have tier 1, tier 2, and tier 3. And in terms of the technical ability, their technical ability increases from tier 1 to tier 3. So the tier 3 are more advanced than the tier 1. So the tier 1 will be the guys who just have basic skills. They can just analyze and be able to, yeah, so the tier 1, they'll be able to analyze and tell whether, there was an attempt to attack the network or not, and things like that. And they'll report that to tier 2, and simply what tier 2 will do is validate. And then if you want someone who will do something like reverse engineering and stuff like that, that will be a tier 3. Yeah, so I've just simplified that, but there are more roles under those 3. Yeah, but for the sake of this course, we are preparing you for tier 1, but then we need you to have an understanding of everything. So so the network security topology, so all networks have to be secured and protected. So, and we talked of tools like the intrusion detection systems and the intrusion prevention systems that we use to and the firewalls, of course, and we also talked of endpoint security. We talked of the anti-malware, antivirus, and such kind of existing tools that we use to automatically, capture traffic that is not good, or malware or anything like that, and report it, or even neutralize it, because the intrusion prevention system will neutralize such attacks. Yeah, and so you get that the IPS and IDS and the antivirus, they give you some sort of automated monitoring, and also an automated reaction to some of the attacks, like the IPS, as I mentioned before. Yeah, by automatically blocking offensive devices or traffic. Now, for large networks, we need something more than just the IDS and IPS, because we have a lot of traffic from different points, and that can be quite overwhelming if it's only one person who is even 2, 3 whose work is to monitor the logs. I can assure you that we have lots and lots of logs that a human being will be overwhelmed if he has to sieve through those and make sense out of those. Yeah, so for that matter, we need tools that can automate this process, that can aggregate the traffic, and also send alerts, that can also be able to group the offensive traffic or devices into some levels of seriousness, so that we have those ones that need immediate attention, those ones that can be looked at later, and so on and so forth. Yeah. So we have so part of day-to-day operations of a network consists of traffic flow, bandwidth usage, and resource access, because people will be accessing resources in a network. They'll be using bandwidth, there'll be traffic flow, of course. Yeah. And so we have over time you realize that we have what we call a normal network behavior. Yeah. And over time, if we have anything that is weird, then we consider that an abnormal network behavior, and that's what these devices most of the times will be configured to be watching out for. And so that's why we have network monitoring, to see if at any point we have any sort of abnormal network behavior. And if that occurs, then we have to investigate that. And that's why we have the analysts whose work is to actually investigate that and to see if we have any abnormal network behavior. And they'll use tools like the IDS, the packet analyzers, and here we're just talking of packet analyzers or protocol analyzers, as it is called at times. Tools like Wireshark and whatnot belong there. We have a simple network messaging protocol, the SNMP, and we also have the Netflow. I think we looked at all this, so right now it shouldn't be confusing to you what these are. And other tools that are used in network monitoring, right? So there are two common methods that we can use in capturing traffic, and those are what we call the taps, the network taps, and the span. So because we have traffic from different points, and getting all that traffic into one place so that you can monitor is not easy. So but we already have ways to enable you, like to collect all that traffic into one central location. And you can use two ways. You can use the taps, or you can use the span. So the taps just stand for the network known as test access points, the test access points, and the span stands for switch port analyzer. And we'll be looking at those two. Yeah. So it's a good thing to know, because if you are designing your network and you're also designing security into your network, then you need to figure out how you're going to, collect all the traffic into one place, and maybe store it in some sort of all the logs. You need to store it into some log server. So maybe you'll have to use the taps or the span. So the network tap, this one is just a passive splitting device implemented inline between a device of interest and the network. And from this architecture, you can see we have the internal network, we have the public network here, and of course we will consider this monitoring to be the SOC. This is where monitoring is done. So we have the tap here that captures all the traffic that is coming from the public to the private network and from private to public. And of course we have firewall and whatnot, and we have strategically placed the tap in between the firewall and the router. So any traffic that's from outside or from within has to be captured, and all that traffic is sent to some monitoring device. Maybe we could have introduced some sort of database here to store all that traffic, so that the monitoring device is just plugged into the database. But anyway, we had to make it as simple as possible for the sake of your understanding. So the network tap here is the one that captures all the traffic, and just to let you know that it's not interfering with traffic flow at all. It's just like getting copies of the traffic that is flowing and storing it. So that when the tap fails, doesn't mean that it's a point of failure for the whole network. No, the network will still continue working, only that will not be able to collect all the logs and store it in one place. So a tap will forward all the traffic, including the physical layer errors, to an analysis device, and so it sends both the transmit, or what we call the TX data stream, from the internal network, and also we have what we call the RX, or the receive data, which is from data stream to the internal network. Yeah. Yes. So basically, I think that is it, and we have a span. So I said there are two ways you can capture all the traffic. So the span, so the span is a protocol. It's a port analyzer, and what it does, it uses the port mirroring technique. I think we looked at that before. So it creates like a copy of the frames, and of course sends that to the central logging server, where we of course plug in the monitoring the monitoring devices. So the thing here is it just creates a copy of the frames. Yeah. So we have the ingress traffic, which is traffic that enters the switch, and we also have the egress traffic, which is traffic that leaves the switch, and of course the span port, which is a source port for monitoring traffic that enters and replicating that or creating a copy of that. So the span is always made part of a switch. Yeah, so we have switches that are span enabled, and we also have some switches that are not span enabled. So if your switch has span capabilities, of course you can enable it to help you handle that. Yeah, so here is a good example of that. You can see that in this diagram we have I can say this one traffic that is getting into the switch, and another traffic that's getting out of the switch, and we have this switch that is span enabled, and it has a port, so the traffic has to go, part of the traffic has to, a copy of it has to go through the source span port, just create a copy of it, and that is sent, that traffic is channeled to the intrusion detection system, or it can be, you can replace that with the log server, where we plug in the IDS, and then of course we have the management server here. Of course, I think that one also handles that traffic. So, and we also have another variation of the span, which we call the remote span, which enables a network administrator to use the flexibility of the VLANs. Yeah. Did we have someone asking a question or something? Oh, you can't see, Abdi, you can't see what? You can't see the image. Okay. Okay. Just the presentation. Oh, sorry. All this time you... too bad. Why did you keep quiet? Sorry about that. I've talked quite a lot and you guys have been quiet. Are you able to see now?
Yes, sir.
Okay. Hey, sorry about that. You should have told me long time ago. I've really moved. I'm almost halfway.
No worry, no worry.
Okay. Right. Yeah. So just for the sake of you guys getting to understand, so we talked of maybe I can. So I talked of the tap, which is it's like a gadget to install into a network in between the public and the private network, and its work is to collect all the traffic and channel it to it can channel it into logging server, because that traffic is in form of logs, into some logging server, and of course you plug in the monitoring device into that logging server, and then you're able to uh, be able to observe the behavior of your network. And another alternative to the tap, we said, is the traffic mirroring, the span. Yeah. Or we also have the R span for remote span. So a span, a span, spans come with the switch. Yeah, as part of the switch. So we have switches that are span enabled and some that are not. So if your switch has the span capabilities, of course you just enable the span. And what the span does is, I mean, the name shouldn't like sound complicated. It just creates copies of the traffic, and then channels that traffic, a copy of that traffic, into a sensor like an IDS or an IPS for monitoring. But generally what normally happens, we need a database to store that traffic, and then we plug the IDS to that database. Yeah, so that's what this figure is all about, and I hope uh, you are able to make sense out of it. So those two ways are what we use to collect all the traffic, yeah, or copies of the traffic, and monitor. Yeah, because we can't have monitoring if we don't have a way of collecting all the logs. So we need to be able to collect the traffic and then later on monitor it. So next, let's look at the tools themselves. So with the network monitoring, generally we have three things when you're doing monitoring. We have what we call the protocol analyzers. We talk of tools like TCP dump and so on and so forth, Wireshark, yeah. And then we have the Netflow. You remember we initially looked at Netflow, which is um, a tool within the Cisco routers that enables you to collect the statistics of your network traffic. So that's Netflow. So with the Cisco Netflow enabled routers, you can enable this feature, and it will be able to give you like the traffic of the network traffic statistics. Yeah, so the most important thing is the network traffic statistics. And then we have the SIME tools, which are like more of advanced tools that enables us to automate most of the things in terms of monitoring. And we'll also look at the SOER, which is built on top of the SIME later on. So what a SIME is a security information and event management system. Yeah. Yeah, and more obviously it's built on top of the SNMP. because the SNMP enables you now like to be able to get information from each and every node that is connected in your network, and yeah, be able to manage those. So yeah, so basically that those three things, so those three groups of tools are very important in network monitoring. Network protocol analyzers, we also call them packet sniffers, like Wireshark, of course. So they just capture your traffic, and so each and every traffic that takes place is captured, and you're able to analyze that in Wireshark. I'm sure in the previous classes we looked at Wireshark and we saw how it works, but don't worry, I'm going to prepare a class just to demonstrate how these tools work in combination. The SIME, I don't know if I'll be able to do the Netflow, but and I mean we have Packet Trace. I think it has that ability. We can simulate one for you guys to just see that, and then so the protocol analyzers will always display what is happening on the network through the graphical user interface. Also, we have the command line options that you can use, like Tshack, yeah, on Linux. So yeah, a very important tool if you want to like dissect the network traffic. So we said that we have different formats that you can use to save the traffic that's being captured by the protocol analyzer, like Wireshark. Like in Wireshark, you can save your file as a pickup file, but there are also other formats. You can find out what those are. So it will store information such as the frame, the interface, the packet length, the timestamps, and all that information. Yeah. And then later on you can store it, and then later on take time to analyze, because sometimes it is I can say it's impossible for you to just analyze while it is capturing, because information is streaming. Yeah, but you can capture and then later on take your time now to sieve through and do the forensics that you want to do to get to understand what's happening in your network. So Wireshark can open files containing captured traffic from other software such as TCP dump utility, because that's an alternative that you can use to capture the traffic, and then use Wireshark to open that. Wireshark gives you like this graphical user interface that makes it easy for you to do the analysis, of course, because if you go the command line way or use the command line tool, then of course it doesn't give you so much of flexibility when you're doing the analysis, because you have to switch commands and whatnot. Yeah, so below this is an example for TCP dump capturing ping. Yeah, so we have WinDump, which is a Microsoft version of TCP dump. So TCP dump should be like for the Linux. Yeah. Yeah, and I also need you to like install the Onion security, because you're going to use that for most of these practicals. Just to demonstrate what we've gone through. And here we have Netflow. We've looked at the protocol analyzer, like Wireshark, and then we have Netflow, which we said it just collects the statistics of the traffic that flows through the Cisco iOS routers in 24/7 statistics all through. Yeah, so it will give you all that traffic. Yeah, so basically that is it. So the Netflow stores flow information in a local cache of the device, but it should always be configured to forward that data to Netflow collector, yeah, which stores the Netflow data in some sort of database, because you can't rely on cache. Yeah, so you need a better way of storing this traffic, and you can always channel it into some form of a database. And here you can see an example of Netflow. So we have this Netflow analyze traffic. So this is a Netflow enabled router. So because I said Netflow comes with it's part of the router, that technology is embedded into the router. So it's enabled, and each traffic that's getting in and out of across the router is captured, and of course we're able to have the statistics at the end of the day. Um, yeah, so Netflow can monitor application connection by tracking byte and packet counts for that individual application, for an application. Yeah. And then it pushes the statistics to an external server, what you call a Netflow connector and analyzer software. Yeah, so, and then lastly we have the SIME tool and the SOER tool. And I said a SIME tool is a security information event management technology, and what it provides real-time reporting and long-term analysis of security events. So to capture all the security event logs, and then later on, analyze. So if you have to do that by yourself, it will take you a lot of time to capture all the events and analyze. I mean, because events are coming. Imagine you're running one node alone in the network, produces lots of events. So there are some events that you don't really need to analyze, so they are more of a noise. So you need to like be able to sieve those, yeah, and just like uh, target the events that you really need to have a look at. So you doing that manually is cumbersome, but using a tool like SIM, it enables you to easily aggregate, like remove those event logs that you don't really need, and then just focus on those that you need. And also the SIM enables you to do reporting, yeah, reporting of if there is um, any alert that needs immediate attention, it will do the reporting, and it can even forward that to the person who really needs to have a look at that. For example, if you have tier 1, tier 2, and tier 3, a part of the SIM is it has the ability for you to create what do you call this? Okay, I'm forgetting, but um, well, I think um, okay, yeah, I'm forgetting this, but well, it can forward the traffic based on severity to the responsible person. Yeah. Um, so the same systems include the following essential functions of forensic analysis. It can do forensic analysis, the ability to search logs and event records from source and provide complete information for forensic analysis. And then it can do correlation. And what we mean by correlation is it examines logs and events from different systems, different sources, right? Um, and then that actually makes it so easy in terms of detection and reaction. Yeah. And then we have aggregation, which is it reduces the volume. As I said before, it reduces the volume of events. So it just like it removes those events logs that you don't really need, and just focuses on filters and leaves you with the events that you really need to look at. Yeah. Yeah, and reporting, because so this reporting that I was talking about, and I was forgetting something which you call ticketing. So it can enable you to do ticketing so easily, like once an event that needs immediate attention is captured, then it can create a ticket and forward that to the person who really needs to have a look at it. So we have like tier 1, tier 2, and tier 3. So if it encounters an event that really needs urgent attention from not a tier 1 but from a tier 3, so it will create a ticket and enable you to do that. So the SIM tool comes with the ticketing ability and the reporting ability, which is so cool. So SIMs will provide details on the source of suspicious activity, like user information such as username, authentication status, and location. Yeah, SIMs will also give you device information such as the manufacturer of the device, the model, the operating system, the MAC address, the network connection methods, and the location. And also the SIM tools will enable you to have security posture information, such as compliance of the device with the security policy and updated antivirus file. So generally it will give you a security posture of your network devices. Yeah. So if there are some security policies that some devices that are connecting to the networks, those devices don't reach that security policy threshold, then it will be able to notify you that these devices are dangerous, or yeah, they need one or two, three things. They need patching of the software. Maybe they're using outdated software and something like that, so that you can react accordingly. We have the SOA, and the SOA is just the SOAs are built on top of the SIME, yeah, an enhancement of the SIME, because what the SOAs give you is are not some. They come with the AI ability, and they even with more enhanced automation and response. Yeah, so we call them security orchestration, automation, and response tool, which enhances the SIEM. So they help security teams investigate security incidences and add enhanced data gathering and a number of functionalities that aid in security incident response. So with the, maybe for example, with the ability to with the AI ability in the SOA, then you can be certain that if in case we have any of network behavior that the SIEM can't capture, most probably the SOA will be able to capture that, because of course it uses AI, and it has been it uses pre-trained data, and so it can be able to tell easily if some weird behavior is dangerous or not dangerous so easily, compared to the SIEM. Maybe the SIEM can overlook that, but the SOA should be able to capture that. And also the speed at which it automates tasks, yeah, is quite faster and in a better way compared to the SIEM alone. But anyway, just remember that the SOA is an enhancement of the SIEM, yeah, because it has additional capabilities on top. So SOA solutions will always provide you case management tools that allow cybersecurity personnel to research and investigate incidents frequently by integrating threat intelligence into the network security platform. Yeah, and we talked of artificial intelligence that's used to detect incidents that aid in incident analysis and response. And then so we said that the SOA can automate complex incidents response procedures and investigations, which are potentially labor intensive if you have to have someone handle that manually. Yeah. And then another feature that comes with the SOA is that it gives you it gives you a dashboard and reports to document incident response to improve SOC key performance. And we'll be looking at those, because I told you we'll have a class where we'll do this practically, but I'll also need you to take time to interact with these tools at your own time and space. That way you really get to have a feel of how things work in a SOC. Yeah. So SOAS will help the analyst respond to threats promptly. Yeah. So they are very important in a SOC. You can't have a SOC without one. You really need one to be able to be efficient and effective. Yeah. So some of the tools, because generally just said SOA, SIEM, so some of the tools that you can use, the examples of SIEM tools. So it's an example of an open source. We said Security Onion, and I told you please find ways of installing Security Onion. You need a good PC to be able to run it comfortably, but you can install on a virtual machine. Yeah. So a Security Onion includes the following tools. It has it's like a toolkit. A Security Onion is a toolkit, and it has ELK, and we look at what ELK is. So ELK is an acronym that actually stands for Elasticsearch. E stands for Elasticsearch, which we know it's a feature that enables you to easily search. It's a search engine. It's an efficient search engine that enables you to search through search through documents or logs. So if you want to do a search through logs and stuff, then you use Elasticsearch. And then we have what we call Logstash. And Logstash, what it is a pipeline processing system that connects inputs to outputs with optional filter in between. So when you're getting logs from all sources, you want to like store all those logs into one storage location. Most probably you will use Logstash, will be a tool that you will use for that. And then we have the Kibana, which is a browser-based analytics and search dashboard for Elasticsearch. So Kibana is the browser interface that you interact with. But then Kibana, of course, is connected to Elasticsearch, and then the Logstash that does the collection of the logs and helps you to sieve through the logs. Yes, so ELK is an important bit of the Onion security. We have other SIME tools like the SolarWinds Security Event Management Event Manager. So you'll hear some organizations use SolarWinds. Some organizations tell you they use Security Onion. We have some other organizations that will tell you they use Splunk. But SolarWinds and Splunk Enterprise Security, these ones are proprietary SIM tools. You have to cough some cash to use those. But Security Onion is open source. It is free. You can just download it from the internet and configure it accordingly, and you're good to go. So it's a good place to start if you really don't have cash or finance to install SolarWinds and the other one. And then we have so we'll do this activity, but we'll still use Packet Tracer to do the logging and whatnot. Maybe also set up another lab where we will try to see if we can simulate how Netflow works. And also, of course, Security Onion to also see how we can be able to make sense of the logs that we collect. Okay, so I think that marks the end of this class for today, and the things we've looked at for those ones who just joined in late. We looked at ways of mitigating threats. So using defense in-depth approach, and when you're talking of security defense in-depth, then we're talking of the security infrastructure that has the following: has firewalls, has IDS, has IPS at some layer, has endpoint security software at some layer, and so a security analyst needs to be in a position to review all the alerts that are generated by network devices and also validate them. So at this point of validation, you'll hear people talk of if an incident is true positive or true negative and stuff like that. But then these devices help you to, so these devices will report to you, will give you a report of the events, but then you have to validate. That's why we need a human person to do the validation, to actually tell whether the event is worth looking at or it's just a false alert. So that's why we have the security analysts tier 1 who just report the events that have taken place to tier 2, and the tier 2, I think it's the work of the tier 2 to validate whether it's actually an incident or not. And if it's an incident and it needs further investigation, for example, it needs like reverse engineering or stuff like that, then can forward it to create a ticket and forward it to tier 3. So we need also some form of ticketing and reporting, and we set the SIM tools that do that work quite well. So you have tools like IDS, packet analyzers, and SNMP and Netflow, and others that are used to determine normal network behavior. And I need you to take time to read further on SNMP and Netflow and the SIM tools before we get to the next class where we'll be doing these things practically. I'll try and set this and So two common methods that are used to capture traffic, we said we have the tap and the span. And of course, the span also has another alternative for rspan that you can use to in VLAN environment. Yeah. And we looked at those quite extensively. And then some of the tools we mentioned, Wireshark and TCP dump for protocol analysis. And we also have another tool that can give us the statistics, network flow statistics. That's why we call it a Netflow. And that is a Netflow tool that's embedded into the Cisco iOS router, and it gives you 24/7 statistics. And we also looked at the SIME tools and the SOER, yeah, for real-time reporting and long-term analysis of security events. And I think that marks the end of it. Unless any one of you's got a question, I will call it uh, the end of this first session. I'll create time also and see if we can have a second session from 3. Quite busy today, but I'll squeeze some time for you guys. So do you have any questions?
So
Yes.
I'm still having a problem accessing the exams after doing a module.
Okay. So you see me on Monday, and then I think I can talk to Prof, and we can fix that.
Okay.
Thank you.
Where can I find you?
Just at the hardware lab.
Okay, in Lillian View.
Yes.
Okay, sir.
Welcome. Okay. So see you at 3. Hope you can go through some 2 more modules if time allows. Yeah. Otherwise, you have enjoy your day.